Alright, so now we're going to be looking at surface area of pyramids and cones. So you guys are going to be now finding the surface area of pyramids and cones by finding the sum of the areas of all the surfaces. So let's review some vocabulary words. Pyramid. So again, a pyramid a pyramid is a polyhedron in which one face, the base, can be any polygon, and the other faces, the lateral faces, are the triangles that meet a common vertex called the vertex of the pyramid. As you guys see right here, so the pyramid has one base, and notice that the lateral faces are all triangles, and on top here, all those triangles meet up at the vertex. So again, the altitude and the height are the same thing, so it's inside of the pyramid, that's the height. And then you also have a different type of height, which we call the slant height. And usually they use this little cursive L to represent the slant height. So it's basically the length of the altitude of the lateral face of the pyramid. So it should be the slanted height. So same thing, you name a pyramid based on its base. So if you have a square as its base, it's the square pyramid. If you have a hexagon as your base, it's a hexagonal pyramid, pentagon, pentagonal pyramid, etc. So here's now how you're going to find the lateral and surface area of a pyramid. So the lateral area of a regular pyramid is half the product of the perimeter, P, of the base and the slant height, L, of the pyramid. So the lateral area is defined as 1/2 the perimeter times the slant height. Okay, so there might be cases where you're not given the slant height, so you're going to have to look for it. Then the surface area is basically the slant height plus the area of the base. So again, back then when we're dealing with prisms, it was 2 times the base because we had 2 bases. The pyramid only has 1 base. So again, the big B is the area of the base. So if it's a square, it's the area of a square. If it's a rectangle, it's the area of a rectangle. If it's a pentagon, it's the area of a pentagon. Triangle, area of a triangle, etc. So in simplest forms, the surface area is just 1/2 the perimeter. The perimeter again is the perimeter of the base times the slant height plus the B, which is the area of the base. So here I broke it down again, kind of the same idea. So if you had a square pyramid where the base is a square, it would be 1/2 the perimeter times the slant height plus the area of the perimeter, which is based on, the area of the square, which is based on height. Here, if you had a hexagonal pyramid, then it would be 1/2 the perimeter of the hexagon times the slant height plus 1/2 the apothem times the perimeter. So again, this is the big B. So now let's go ahead and we're going to look at some examples on how to find the surface area of a pyramid. So similarly as we did the surface area of a prism, here we're going to go ahead and find the perimeter of the base. So let's go ahead and find the perimeter of the base. So the base is a square. So all sides are 12. So the perimeter of this base would be 4 times 12, which is 48 inches. Okay, so that's the perimeter. And then we're given the slant height. So the slant height here is 11. So that'll be my slant height. All right, so now let's go ahead and find the surface area. So remember, the surface area is the 1/2 the perimeter times the slant height plus the area of the base. So now let's go ahead and rewrite this. So it's going to be 1/2 perimeter times slant height plus the area of the base. So it's basically the area of a square, base times height. So now let's go ahead and substitute in the values. So it's going to be 1/2 the perimeter. So we found the perimeter was 48 times the slant height, which was 11, plus the area of the square, which is base times height. So it's going to be 12 times 12. So you can go ahead and plug it into your calculator. So once you plug it into your calculator, you should end up with 408 inches squared. All right, so now you can go ahead and pause this video, and you can go ahead and attempt the other example. All right, so now starting off with the other example. So it's similar to the previous problem, so I'm not really going to show the work for this one, but if you did end up solving this one, you should end up with 179 inches squared. So again, it's the same process because the base is a square. So you follow the same steps, but that will be your final answer. And then once you're done, you can go ahead and pause and attempt the other example. Now this example has the base as a hexagon, so again you have to use your 1/2 the apothem times the perimeter for your area of the base. So again, pause this video and attempt this problem before continuing and checking the answer. Okay, so now if you're going to go ahead and solve this problem, again my base is a pyramid, so we have a base that is a hexagon. And again, what's nice about this problem is that we're given most of the information that we need. So we have 6 inches as our side length, and we have our apothem, which is 3 radical 3 inches. Oops. So now we can go ahead and find the surface area. Remember, first find the perimeter. So we know the perimeter is just going to be the side length, 6, times how many sides it have. So it's 6. So we end up with 36 inches. And again, on this one, we are also given the slant height. So we already know our slant height. The slant height is 9. So now we can go ahead and find the surface area. So again, the surface area is 1/2 the perimeter times the slant height plus the area of the base. In this case, it's going to be 1/2 the apothem times the perimeter. So now let's go ahead and substitute in the values. So we end up with 1/2 times 36 times 9 plus 1/2. We already have our apothem, which was 3 radical 3. 3 radical 3 times the perimeter, which was 36. So if you plug it into the calculator, you should end up with approximately 256 inches squared.